Hello guys, welcome back to the third part of the collection framework. Now in this we'll talk about more about collections. Last time we have done with collection interface, then we have used list interface with integer values, then we have used generics. Now in this what we'll do is, now if you remember this example, we took some random numbers, approximately 100 random numbers, and then we have added all those random numbers which should be less than 1000 into my collection, and then I have sorted those values and printed all these values, right? If I run this now, again you will see we will be getting all the outputs in a sorted order. So you can see all these values are sorted in ascending order. Now what I want to print all these values in, it's not ascending order. It should sort depend upon the last value, which means if your value is 1, it should come first. If your value is 5, it should come in middle. If your value is 9, example, if you have this value, let's say this one, so it should come last. Doesn't matter, number is 450, 459. What matters is it is 9. That means I want to sort it in my own way. To use that technique, what we can do is we can use some like example. If I use a sort method here, it has two signatures. This overloaded function. First is sort with list. That's what we are using now. Next is sort list. Now it is comparator. Comparator says you can have your own logic here. That means by default, this sort method, the above one, will sort in ASCII using ASCII values or ascending order. You can see it's specified as ascending order. But what I want here, I want to sort it in my own way. Okay, so we can use something called as mutually comparing. Okay, so how to do it? First, you have to pass the collection, and next here you have to pass the object of comparator, or you have to pass the instance of a comparator. Now, question arises: what is comparator? So, comparator in Java is a interface. So you can see we have a comparator interface belongs to a package util. Then let's get object of comparator here. Let's see if it is num compare. Now, now, since it's an interface, if you go to this class, it's a functional interface, which means it has only one method, and it's an interface which works with generics. It takes a type T, and then it has a function or a method called as compare, taking two values T1, T and O1 and O2. Now, now what we can do is we cannot create instance of comparator, right? So we have to create a class. That class will extend, sorry, not extend. Let's create a class name as number compare, num compare, and this should implement an interface called as comparator. Okay, and in this, since we are implementing a comparator interface which should compare integers, since it works with generics. Now, whenever you implement an interface, you have to define a method which is there in this. Its a method name is public int compare, which will take two values. One will be integer, let's say I1, and integer I2. Okay. Now, how to compare these two things? We have to say return, or we can use if else also. We can say let's say we will say difference. So what we can do, we can just we can sort it in this way. If we can check if, let's say by default the value for difference is 0. We can check in this way. If I1 mod, because we want only last value, right? If I1 mod is greater than I2 mod 10, it will pick up the last value. If this is the scenario, your difference should be -1, or difference should be 1. Else if your I1 mod 10 is less than I2, it's I2 mod 10, then the difference value should be -1, because while sorting, this compare method or this sort method will check for the positive values and negative values. Else you can specify def is equal to 0. Okay, even you don't have to specify this also, because if this two don't execute, we have a difference by default which is 0, right? And then we can say return diff. Simple. And then here what we can do is we can say new num com, because we have a class now which implements comparator, and then we can pass here something called as new comp. Simple, right? So this is how we have to use comparator, and if I run this, you will see the output is we have all these numbers and they are sorted with their last value. So you can see it is 0, 0, 0, 0, then 1, 1, 1, then all twos, then 3, then 4, then 5, then 6, then 7, right? So it's working. Now if you see here, we are doing this if else part. Now you can do the same thing with something called as ternary operator. Now how to use ternary operator? We can simply say it is diff is equal to if my I1, let me use the code. So it is diff equal to I1 mod I2. If this is the scenario, then question mark, it should be 1. Otherwise colon, and then we'll use this condition. If this is also, if this works, it should be -1, right? Am I missing something here? It's colon, question mark, colon. Okay. And then we have to say else, it should be 0. So we can directly define int diff. So it is same like if, else if, and else. Now, if you want to define it this way, you can also remove this variable diff. So you can directly say return this value. Okay, so this is how you can reduce the number of lines in your code. And we have two semicolons. Okay, simple, right? If I run this code now, it will still work. It will work. Okay, now so this is how you have to use comparator. Now, if you see, the only reason why we are creating this class here is just to implement comparator, right? So what we can do is we can simply, instead of using this num comp, we can simply create object of comparator using inner class. So we can create object of we cannot create the instance of interface directly. We have to use something called as inner class. So after this constructor of comparator, we have to give a curly brace open and close to define the implementation. In this implementation, we can use this method. So we can say cut and paste. So we don't require this class here, right? Simple. Is it? Am I missing something now? It's giving an error. I'm using compare. Okay. Now, whenever you use this type of integer, the problem is when you say comparator and when you say compare, so it should match a signature. By default, the signature here of this comparator or this type of this comparator is by default object, which means this should also be an object. This should also be an object, right? But we want to compare integers, right? So that's why we have to mention this should be an, what is that? Yeah. This should be an integer. Now it will work. And here also we should mention it should be integer. Okay. So now if I run this, it's working. That means we can reduce the number of lines with the help of inner class. Now if you observe, the only reason why we are creating this numcom is to pass here, right? That means we are using that reference only once. So if in this scenario we can just copy this code, since we are using it only once, we can paste it here. This is called as anonymous inner class, because this inner class here doesn't have a name. So this is anonymous inner class, right? So you can reduce the number of lines again. Now what next? Now if we talk about this part, if you can focus, this Comparator here, it's a functional interface. And Java 8 says whenever you have a anonymous inner class of a functional interface, you can use lambda expression. What it means, this boilerplate code from here to here, we don't require this code. It's because by default, collection will ask, obviously it's asking for a comparator object, so why we have to pass this? And obviously in comparator interface, we have only one method, which is compare. So why to mention? Now JVM is smart enough to guess this value and this value. So we can remove this part. We can directly mention we want two variables, and in this we want two objects, and in this method, so this is the signature of your compare. In this method we require this definition. Okay, so we can, I think I close wrong. Okay, and we can simply write this case, right? So we have reduced the number of lines. Again, what we know is this collection is a this C is a part of, it's a type of integer. So why we have to mention integer here? Again, your JVM is smart enough to guess the type of the values, right? And you can write this thing. That's it. So this is how your comparator works. So you can see we have reduced the number of lines. In fact, lots of lines, and that's the advantage of Java 8. So this is comparator. In next part, we'll talk about comparable. Thank you so much for watching, and do subscribe for further videos.